Hello folks, this is Cambridge Pre-University Certificate 2013 May-June paper 1 and the question number is 7. This question is concerned with projectile motion. This is a part of our course. So it says that a clay pigeon is launched vertically into the air from the ground. So we have a launching device here. So we have a model pigeon made of clay launched vertically into the air from the ground. It goes up and then descends back. A marksman here lies 170 meter away from the launching device, 170 meter away on level ground. So the ground is horizontal. It means just as the clay pigeon reaches its maximum height of 60 meter. So as soon as it reaches here, it comes to rest. At that time, the marksman fires a bullet aimed directly at the clay pigeon. So the marksman strikes the pigeon when the pigeon was at rest at this position. The bullet leaves the rifle with the speed of 20 meters per second. So it is u actually. This is the initial velocity of firing. At what time after the bullet is fired? So at what time after the firing is the clay pigeon hit? So assume air resistance is negligible. So what happens here is the marksman fires the shot when the pigeon was here. So after that, the pigeon falls like this, and the bullet that he strikes, so he is actually aiming directly at the pigeon, like this. But when he fires the bullet will follow a curve like this. The bullet will follow a curve somewhat like this, somewhat like this, somewhat like this, somewhat like this. So when the pigeon reaches here, the bullet fires the pigeon. So it's because the air resistance is negligible, which means that the vertical motion is just affected by gravity. The vertical motion is just affected by gravity. So that means had there been no gravity, the bullet would have gone like this, and because of gravity, it descends this much height. So the height descended by the bullet as well as the pigeon should be same, which makes the bullet strike the pigeon here. So it's not of something strange thing, it is just a normal thing. It is that the vertical distance traveled by the bullet, descended by the bullet, and the vertical distance descended by the clay pigeon is equal, and that's why they meet each other in air and they strike each other. So this is the motion of the trajectory of the bullet. So first what we have to do is, we have to find the time here. We have to find the time after which the bullet fires, the bullet hits the clay pigeon like this. So first what we need to do is, we need to find the angle, this angle. We need to find this angle. So this angle is given by, so tan theta is equal to 60 by 170 equal to 6 by 7. Tan theta is equal to 6 by 7. Now let us move on with the calculation. So what happens is for the projectile, the vertical displacement at this time, let us say this is equal to y1 actually, y1. So y1 should be equal to u sine theta into t minus 1 by 2 gt square. So it's the equation for the y displacement of the projectile. And for this thing, it descends this much height. So this let us say this height is equal to y2. For the clay pigeon, the y2 will be equal to simply 1 by 2 gt square. So it is the time after it reaches the top, or let us say the time after the bullet fires. So when I add these two, so y1 plus y2 becomes u sine theta into t minus 1 by 2 gt square plus 1 by 2 gt square. So this and this cancel. Now what we have is y1 plus y2 equal to 60 meters. So 60 is equal to u sine theta into t. This u is equal to 300. So therefore t is equal to 60 divided u sine theta equal to 60 by u is 300 sine theta equal to, this is 5, so it is 1 by 5 sine theta. So the main thing here is we have to find the value of theta actually from this value, and we use the value over here. So for that I require calculator. So let me find the calculator here. Let me find the calculator, or the value of tan theta will be okay, now then we given by 6 divided 17 equal to so when shift to 10, it will be 19.44 degree. So theta will be equal to 19.44 degree. So it's the same thing here. It will be 1 by 5 sine 19.44 will be equal to, so this thing will be equal to this sine into 5 equal to then one by reciprocal equal to, yes, 0.6. So it is 0.60 seconds. So going through the answer choices, we will have now choice number C will be the correct answer. So after rigorous derivation, we are arriving at choice number C.